Alright, so today we're talking about law of parallelogram of forces. It states that if two forces acted on a body are represented in magnitude and direction by the two adjacent sides of a parallelogram, then their resultant may be represented in magnitude and direction by the diagonal of the parallelogram, which passes through their point of intersection. So what does it mean? So we're going to having two forces, F1 and F2 are the two forces that is acting on the body A as shown in this diagram. So this is the body. So these are the two forces, F1 and F2. It says if two forces acted on a body are represented in magnitude and direction. So these are the magnitude. Then the direction is this triangle that's showing their direction by the two adjacent sides of a parallelogram. By the two adjacent sides of a parallelogram, meaning when you consider these two forces, they are acting as the two sides of a parallelogram. That is the two adjacent sides of parallelogram ABCD. This is ABCD. Then the resultant may be represented in magnitude and direction by the diagonal or the parallelogram which passes through the point of intersection. So this is the point of intersection here. The diagonal is represented, the resultant is represented by the diagonal. So it will be this will be the diagonal. So that will be the diagonal. So then we'll move to the proving of the formula. So we're going to drop a perpendicular line from this C on the line AD. This is the line AD here. From this C on the line AD at point E, which is this one that you draw here. So from the angle BAD, is equal to, the angle there is theta. Then likewise the angle CDE is also theta. Why? Because they are parallel to each other. This is angle AB and CD. They are parallel to each other, so that's why. And that's also here, this one is F2 and this one too is F2 because they are parallel to each other. Then from the angle CDE, angle CE is equal to F2 sin theta, angle CE, that is from here, F2 sin theta, while angle DE is equal to F2 cos theta. You may be asking why. The reason is that if two forces act at an angle, they are acting at an angle, so there are two components there. That is the vertical component and the horizontal component. So the one that is acting as the adjacent will be cos, so it will be F cos theta, while the one that acts as the opposite, which is this side, will be F sin theta. So that's why here in this angle CDE, this is the opposite, so it will be F2 sin theta, while the adjacent will be F2 cos theta, because the force act at an angle. Then from right angle triangle, angle AEC, this angle AEC, using the Pythagoras the hypotenuse square plus the opposite is equal to opposite square plus adjacent square. So the hypotenuse is this one, which is the resultant, AC square, this is it, AC square equal to AE, that is the adjacent, AE square plus EC square, which is opposite, EC square. But you know this AE comprises of AD plus DE. This is it here. Then we bracket them, square plus AC square. AC square. Then we start putting in the value, which is r square. This angle AC is r, which is the resultant, r square into bracket angle AD is f1 plus angle DE is equal to f2 cos theta, which is f1 plus f2 cos theta. Then we square them plus angle EC square, which is angle f2 sin theta. Then we square them. Then we begin our normal calculation. That is, then this one they are squared. Then we expand them. It will be f1 plus f2 cos theta bracket, then that bracket f1 plus f2 cos theta bracket plus this one f2 square, f2 sin theta square, it will be f2 square sin square theta. So when we do this one, it will be f1 times f1 square, f1 times f2 cos theta, it will be f2 cos theta. Then same thing here, f2 cos theta times f1, it will be f2 cos theta. Then f2 cos theta plus f2 cos theta, it will be f2 square cos square theta. Then plus this one, f2 square sin square theta. Then it will be f1 square plus, because this one we added them together, f1 f2 cos theta plus f1 f2 cos theta, it will be 2 f1 f2 cos theta plus this one here, which is f2 square cos square theta plus this one here also, f2 square sin square theta. Then we move on, it will be f1 square plus 2 f1 f2 cos theta plus, you know here, f2 square is here, they are common to both of them. Then we bring out the f2 square, then we bracket them. It will be f2 square into bracket cos square theta plus sin square theta. And we know, according to the trigonometric this thing, cos square theta plus sin square theta is equal to 1. So everything here will be equal to 1, which is why we have f1 square plus 2 f1 f2 cos theta plus f2 square, because everything here is equal to 1. Then we bring back our r square is equal to f1 square. Then we bring this one here, f2 square plus 2 f1 f2 cos theta. Then by removing the square here, you put square root on all this one. It will be r is equal to square root of f1 square plus f2 square plus 2 f1 f2 cos theta. So this will be our formula. And then if we are finding the direction of the forces, we know these are the side of the forces. We have adjacent and opposite, and we can use tan. This is tua, opposite over adjacent. So it will be tan alpha equal to CE, which is the opposite, over adjacent. Adjacent is AE. Then we know that our CE over AE is equal to AD plus DE which will be equal to f2 sin square theta plus f1 plus over f2 cos theta. Then we are looking for the direction, so it will be 5. So our alpha is equal to tan inverse of f2 sine theta over f1 plus f2 cos theta. So that is it. So according to the law of parallelogram, they say that if these two forces acting on a body are represented in magnitude and direction, this is the magnitude and these are the direction. These are the direction. By the two adjacent sides of a parallelogram, then their resultant may be represented in magnitude and direction by the diagonal of the parallelogram, which passes through their point of intersection.